All right, so now we're going to talk about data structures and looking at our course outline. We did loop. We did conditional if, else. We did switch and case. For some reason, I always forget that, but it seems like it's pretty straightforward, right? Like, I'm going to switch on these different cases. It's not like you're going to case on these different switches, right? It's switch and then case. And you could switch on bool, whether it's true or false, or you could switch on this value and then which case is the right one. And so those are switches and cases. It might be fun, you heard me pause there for a second, just to practice that for 1 second, experiment with it. So I'm going to, I guess, go into the conditional folder and go into more, and then do func. I don't know, what comes after monkey? Cat? Monkey cat? And then we could have x colon equals 42, and we could do switch on x, and then we could have a case where my thought was, what was my thought? I totally lost my thought. I don't know what example I was going to show you. I don't know, that thought's gone. All right, so then we have those, and there's some hands-on exercises there, and then we're getting into grouping data. And so grouping data, we start to work with aggregate data structures or composite data structures, and aggregate or composite data structures aggregate or compose together data from many different values or many different values and different types. And so those phrases are good to know about, aggregate, composite data structures. And the first one that we'll look at is a slice. And so it's kind of interesting, aggregate data structure, wiki, let's see what comes up. Data structure, wiki, is an aggregate data structure, also called a tuple or a struct, right? Composite data structure, and composite data type. In computer science, composite data type or compound data type is any data type which can be constructed in a program using the programming languages, what? Using the programming languages, what? Primitive data types. Primitive data type is a basic data type provided by programming languages, basic building block, right? Many languages allow more complicated composite types to be recursively constructed. And so it is sometimes called structure or aggregate data type. So we have these phrases, this terminology, composite data type, aggregate data type, and sometimes called a structure. So we're going to start to look at composite aggregate data types, and they allow us to compose stuff together. And the first one we're going to look at is a slice. So I'm going to do main.go and package main and func main. And the easiest way to create data structures in Go is with something called a composite literal. And so we'll use x colon equals. We know what that is, right? And we could use a primitive data type, like an int is a primitive data type. Or, right? Or a string, hello world. Those are primitive data types, right? A, hello world. B, colon equal 42. C, colon equal true. Those are primitive data types. They're the basic building blocks. We've got string, int, bool of those primitive data types, just giving you terminology. Int, bool. How many people like the terminology? Because programming has a language which is all its own, and so if you aren't familiar with some of these things, when you read stuff, you'll be like, primitive data types, first-class citizen, composite, aggregate data types, you know, what's going on? But if you learn what they are, then it makes sense. So those are all primitive data types, basic building blocks. And they're also first-class citizens. meaning, you know, you can return them from functions, you can pass them into functions, you know, and also just remember we're talking about values and types here. It's static programming as opposed to JavaScript's dynamic, loosey-goosey. So now we're going to look at a composite data type. And the easiest way to do a composite data type is with I am spacing on the term, hold on, composite literal, with composite literal. And so composite literal is going to be the type and then the values, okay? That's what a composite literal is going to look like. So composite literal is, what do they call it when it's a coding convention? What do they call that when it's a coding convention? It's what? I can't think of it because it's late. It's, you know, the way you do stuff with code. What's that called? Yeah, syntax isn't quite what I'm looking for. But it's a convention. It's a coding convention, right? So here's composite literal. It's the type, and it's going to be a slice. And then I'm going to, it's going to be a slice of int. So that's the nomenclature for a slice right there. Okay, that deal. And then you put the values that you're going to store there, and you put as many as you want values in here. So now I could do, you know, 42, 43, 44, 45, 1024. And that's my slice of int. And then if I do my func.println, and I do my A, B, C, and as easy as 1, 2, 3, and then my X, because I have to use variables, otherwise it's an error. And then save all this, and bring up my terminal, and CD up a level, and do 012, and go run main.go. I've got hello world, 42, and true. Those all came from up here, just so we don't have confusion. Let me take that out and make that a 4. Hello world, 4 and true, and then we have 42, 43, 44, 45, 1024. So a slice is like an array in other programming languages. There is an array in Go, but an array is a data structure that we don't normally use in Go because it's not dynamic. You set its size, and its size does not change. And so instead we use a slice, which is built on top of an array. So beneath a slice there is an array. We don't see that. The internals of Go takes care of it for us, but the slice is dynamic. So as you change the size of the slice by adding values, the underlying array will automatically be changed by Go's runtime. There are some performance considerations to think about, right? Because you don't want to keep destroying and recreating arrays in the background beneath your slices, because that will impact performance. It's better to create the array the right size underneath your slice the first time. There's a way to do that. That gets into the next video, or the video after that's info. But the main info you want to get from this video is that this is how you use a composite literal to create a slice, and a slice will store values of the same type. Notice what this says. It says this is a slice of int. I can't put strings in there. I can't put bools in there. I could put ints in there, not float 64s, just ints. And if, in fact, I look at that print f and look at x, the type of x is %t, new line, and then pass in x. The type of x is, not liking that, %T. Type of x is slice of int. So that's the type of x, is a slice of int. So again, I have the type, the curly braces, curly brackets, braces, curly braces, and the values in between. So that's how we do a slice of int. Any questions? I sound tired, don't I? I'm like, la, 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 la. How monotone can I make this? All right, you want to try coding it or you want to move forward? Raise your hand if you want to code it. Raise your hand if you want to move forward. 1, 2, 3, 4, 5, 6. Cool, we'll move forward to the next video.